Hey, welcome back to your favorite Math 120 course, you guys. Fundamentals of College Math. We're going to take a look at percentages. So, what does percent mean? Percent. Cent, 100, right? Per 100. So, when you say 40%, that's parts per 100. That's 40 parts per 100. 40%, right? And of course, you could punch that in. 40 divided by 100 is 0.40. Right, so since you're dividing by 100, really all it's doing is it's taking that decimal and moving it over to, right? So this is your percent form. This is the decimal form right here. 40% is the same as 0.40, right? Of course, if we kept it as a fraction form, 40 over 100, that's 4 times 10 and 4 times 25. So you're left with 10 over 25 is the same thing as, but we could keep going further, right? 10 is 5 times 2 and 25 is 5 times 5. So 2/5 is the same, is a fraction form, simplified fraction form of 40%, right? 40 over 100, same thing as 2/5 on that. So let's go ahead and put the fraction, decimal, and percent form for each of these. Let's fill in the blanks. All right, so we got 3/5. So I just take my calculator and just go 3 divided by 5, and it spit out 0.6. Or if you want to do it by hand, I guess you could do it by hand. 3 divided by 5, 3.0 divided by 5. So I'm going 5 into 3 is too small, right? But 5 into 30. 6 times 5, 30. Decimal goes straight up. Anyways, that's how you do it by hand, right? 0.6, if you've forgotten that. Again, I just punch it in. 0.6. Now, if we convert that to a percent, right? This is in decimal form. 0.6. This is the same thing. 0.60 is the exact same thing, right? So if I did it that way, 60/100ths or 60%, right? So if you're going from a decimal to a percent, one way to do that is you're just really moving it over to, it's parts per 100, right? So 0.6 or 0.60 is 60%. All right, let's do some more now. 0.02. Now they give us the decimal form on this next one. 0.02. So that's the same as 2/100ths, right? But we can simplify that. 2 is 2 times 1. 100 is 2 times 50. So 1/50th is the same as 2/100ths, right? And 0.02 is 2/100ths. In other words, 2%. Or if you want to think about just moving it over to positions, that'll give you that percent there, 2%. That decimal right to parts per 100. Now 72%. This time we're given the percent. 72%. So if I'm writing that as a decimal, that's parts per 100, right? 72/100ths or 0.72. So the decimal's going back to, right? 0.72. 72%. Or 72/100ths, right? And we could keep going with that if we wanted to. 2 times 36, 2 times 50. Both those go into 2, so 18 over 25. Same thing there. All right, 36, 2 times 18, 50 is 2 times 25. 2.5, what would that be? Well, let me move it over twice. That would be 2.5%. Right? 2.5%. And what is 0.025 as a fraction? Well, this is the zero's in the 10th position, the 2's in the hundredths, position, and the 5's in the thousandths position, right? Thousandths. So it's 25 thousandths is how you read that. 25 thousandths. So 25 over 1,000, which 25 is 1 times 25. 1,000 is actually 40 times 25. So this is the same as 1 over 40. 1 over 40 is 0.025, same thing. All right, 4.5, that's kind of awkward. Let's go 2 times 4 plus 1. Let's convert that. That's 9/2, right? Let's put it into an improper fraction. And then, erase this real quick. I just go ahead and divide 9 divided by 2. And 2 times 4 is 8. And with a remainder of 1. So it's 4 plus 1 over 2. 4.5. Oh, I'm sorry. I just did this. What am I doing? I'm trying to put this as a I don't want a fraction again. I'm sorry. Bring the 0 down. There we go. 2 goes into 10 5 times. 5 times 2, 10. Decimal goes straight up. There we go. 4.5. Again, I just punch in 9 divided by 2, right? You get 4.5. But if you want to do by hand, let's say do by hand. As a percent, well, let's move it to the right a couple times. 1, 2. Notice there's no 0 there, right? It's 4. I'm moving it right 2. Oops, right. 1, 2. So 450% is actually what that 4.5 is in percent form. With these subsequent examples, what we're going to do is we're going to set up with the English, we're going to set up an algebraic equation. Okay. So what percent? So we're looking for what, right? So I'm going to be like, okay, that's my x. What percent of, meaning multiply, what percent of 200 is, meaning equal, is 30. What percent of multiplying is 30? What percent of 200 is 30? So I'm just solving if 200 times x equals 30, how would we solve that? And that'll give us the percent that we want. Now it's going to spit it out in decimal form. So let's go ahead and divide both sides by 200. And I punch that in. I got 30 over 200 is 3/20, which is 0.15 when I punch that in. Now, they don't want the decimal form, right? They want what percent is that? Well, what percent is that? I move it the decimal to the right to 15%. So this is saying, so let's think about it. Is 15% of 200 equal to 30? Sure it is. All right, 0.15 or 15% of 200 is 30. So that's how you can check that. Let's do the next one similarly. 6 equals 7.5%. Now you want to work with percentages. This needs to be a decimal. So put it as a decimal. That's 0.075. Of, multiply, what number? What number is going to be my x? So 6 is 7.5%. Again, you got to have that in decimal form when you're working with it mathematically. 6 equals 0.075x. So 0.075x equals 6. Let's solve for x. Divide both sides by 0.075. 6 divided by 0.075 will spit out 80. So this is saying 6 is 7.5% of 80, right? 7.5% of 80 is 6. What number is 20% of 350? So my what number is going to be my x, right? Is equals 20%, but we got to make sure that the 20% is as a decimal. What is 20% as a decimal? 0.20, yeah, so 0.20 of multiply 350. So I just got 350 times 0.2. That just ends up being 70. In other words, 70 is 20% of 350. Makes sense, right? All right, so we got 243 out of 400 people out of 400 in the state. 243 people out of 400, good grief, state that they like dogs. 243 out of 400. So I just punch this in. What percent is this? So I punch that in, 243 on my calculator, divide by 400, and I get 0.6075. But what percent is this? Remember, that's got to move that over a couple times. So 60.75%. So 60.75% people like dogs. Let's try this one. The next one, to win the election, President of the U.S., you got to have 270 out of 538 from the Electoral College. This is a good one to pause and try, of course. 270 out of 538. Punch that in as well. And we'll round it to the nearest percent. So 0.50185873661. I punch that in, but we want it as a percent. Let's move it over to percent, but we want it to nearest tenth. Right there where the 1 is. So I look to the right of the 1, it's an 8, that'll bump that up, right? If it's a 5 or more, it'll bump it up. So 50.2%. Sales tax in town is 9.4%. So how much tax will you pay if you spend $140? You spend $140, you got to pay 9.4%. So really what we're asking is, what is 9.4% of 140? So let's multiply it. But I got to have that as a decimal, right? So convert that to a decimal. 0.094 times your 140. That's what your tax is, just the tax part. So the tax ends up being 1316, right? That's your tax. So what's your total? Well, you still have to spend 140, and you got to pay your taxes. Curse those dang taxes. $153.16 is your total bill. So here we got 28% of, so we're going to multiply 28%. Make sure you put it as a decimal when you work with it mathematically. 28% of the 750. So that gives you, there's 210 out of the 750 people would be 28%, right? So 210 would vote straight Republican according to this data. Let's move on here to example 5. Lender requires minimum down payment 12% of the value of the home. And we have $22,000 to put down as a down payment, $22,020. Okay. So how much would be the maximum home value that you could potentially qualify for? Well, let's write it down. Our down payment has to be 12%, so as a decimal, of the value of the home, X. Let's let X be the value of the home. 12% of the value of the home is our down payment. Now we have $22,000.20, or I'm sorry, $22,020. So what's the maximum home value that we can finance? Well, let's solve for X here. Divide by 0.12, divide by 0.12. X would end up being $183,500. And you will not get a home in Las Vegas for that, unfortunately. I wish it were so, but probably not. Unless it's a condo or something. Today's dollars. So section 4.3, we get into absolute and relative change. And so what you want to think here is like, what's the difference in price over the base? So let's do this first one. So I'm thinking to myself, what's the ending price minus the original starting price, and I'm going to compare it to the original starting price, and that'll tell me the percent, in this case, percent decrease. So 7,400 went from a $7,400 value down to $6,800. You know, cars obviously go down in value, so it ends up at $68 a year later. Maybe you bought it for $7,400, but we're comparing it to the original $7,400. So I got negative 600 over 7,400. I punch that in. Negative 0.081. The negative is indicating that's my decrease in price, right? It's gone down. It's decreased. How much as a percent? Well, let's move it over a couple. 8.1%, right? So we've decreased 8.1%. All right, example 2, we got 75 of these QFC markets, supermarkets, and Albertsons got 215 stores. Compare the size. Let's do the first one. Let's compare it with QFC as the base price, so the denominator, right? So we're thinking to ourselves, what's the difference between the two, and then compare it to the base. So there's 215 of these Albertsons minus 75 of these QFCs. We're comparing it to the QFCs as our base. So we've got 140 over 75, or 1.867. So in other words, well, let's make that as a percent. Let's move it over to 186.7%. So Albertsons is 186.7% larger, because we compared it to the base being the QFC, larger than QFC.
How do you know that?
So that's solution 1. Let's do solution 2. You could also do Albertsons as the base when you're comparing the size of these two companies. Right, and then that would be, absolute value of the difference. I should have slapped absolute values on that, but it was positive up there. So we have 75 of these QFCs minus 215 Albertsons. We're comparing them to the Albertsons being the base. And so we've got negative 140, but I'm taking the absolute value of that, so it's just the 140 over 215. And so I punch that in, I get 0.65116, or 65.116%. So I'd say, okay, QFC then is 65.116% smaller than Albertsons. What you note, either of those two could be the solutions for that one, you guys, but let's note a couple other, could do the following comparisons as well. You could do, there's 215 Albertsons, you could make this just a straight ratio compared to 75 QFC stores, which would be 2.867. So like Albertsons, the top one, Albertsons, is 2.867 times the size of QFC. That's another comparison. Or 286.7%. All right. One other one. What if we did QFC relative to Albertsons instead. All right, so 75 over the 215, or 0.349, or 34.9%. So QFC is only 34.9% relative size of Albertsons. That's another one. Let's suppose, you guys, that we got a stock here, drops in value by 60% and then increases by 75%. Do you think that thing is higher or lower than where it started? And let's suppose it was $100 stock. Let's suppose we had this $100 stock, right? Well, if it goes down by 60%, let's see what that would be. $100, 60% of $100 is $60. Okay, so now we have, at the end of week 1, we went down $60. We were at $100. I went down $60, 60%. So now I'm at $40 at the end of the week 1, right? But then it increases. How much does it increase? Now it increases 75%. So let's go. I have my $40. It goes up 75. Well, what's 75% of $40? It would be $30. Okay, so the end of week 2. Remember, we were sitting at $40, right? Because it dropped 60%. But then we're increasing 75% of $40. We're increasing $30 that week. Where are we at? We're $70 is where we ended up. So where did we start at? We started at 100, right? We started at $100, so we're lower. So we're only at $70 now than where we started. One more before we get into 4.4. Politicians support increases from 40% of voters to 50% of voters. What's the change? Well, we ended up at 50%. We started at 40%. We're comparing it to the original 40% of voters support that we had, right? So we have 10% out of 40%. Of course, your percents are canceling on that, you guys. 1/4 or 0.25, or a 25% increase in support as compared to the original amount that supported you. 25% increase. So this is like your relative increase. You know, what was the absolute increase? The absolute increase is just how much it went up by total. The absolute increase, that's just the difference. You know, when went from 40 up to 50%, right? So that's an increase of 10%, absolutely, right? But as it compares to the original, it's a 25% increase. All right, so before, we did relative or percent change. Now we're going to use percent change to determine the future value of a quantity. So for example, you hear tuition is supposed to increase by 7%. If tuition this year is $1,200, what will it be next year? Well, step 1, what is 7%? 7%, 0.07 of 1,200 gives you $84. So you're going to have a 7% of 1,200. You're going to have an $84 increase in your tuition next quarter, right? So what would it be? Well, if tuition was 1,200 and it goes up 84, or 7% of that, now we end up with a $1,284 tuition bill. a TV is priced originally at $869, but it's a 35% off sale. So what's 35%? Change it to a decimal of 869 would give you get $304.15 off of it. So what's the sale price? Well, originally it was $869, but I get 35% off of that, which we know was $304.15. So it looks like we get this TV for $564.85 after the 35% off sale. And why don't you guys try this one? Go ahead and pause the video. All right, part A, the bill for dinner is $85.20. You want to leave a 15% tip. 15% of $85.20 ends up being a $12.78 tip. So the total bill would be the $85.20 for the meal plus the tip, which is $97.98 is your total bill with the tip. Let's do part B. Clothing store 15% off. 15% off of something that was priced at $74, 0.15 times 74 ends up being $11.10 off. So the sale price would be, it was originally $74, but I'm getting 15% off, $11.10 off of that. So it looks like it'll end up being $62.90 is the sale price. Well, thanks so much for watching. See you next time.